And I would really like to introduce Dr. Richard Miller, who's here with us today. And Richard's a strategy consultant and leader in innovation, specialising in sustainability and the built environment. Richard has got over 40 years of practical experience in sustainability and innovation, and has worked across numerous industries, both in the private and the public sectors. In particular, Rich has worked with Innovate UK. He's developed and implemented their built environment and urban living programmes, as well as managing wider programmes in sustainable agriculture, energy, health, care and resource efficiency. As an associate at Connected Places, Rich's focus has very much been on the built environment, and in particular the challenge of retrofitting housing stock to meet our 2050 environmental targets. As part of this, Rich has led workshops, he's prepared many reports, he's worked in partnership with various stakeholders and other organisations to develop joint approaches to tackle known market failures in energy retrofits and creating viable pathways to net zero carbon. So Rich is in a perfect position today to talk to us about net zero built environment. Over to you, Richard. Thank you.
Thank you very much, Julianne. So good morning, everyone. I've been working in and around the problem of improving our building stock for 15 years, and today I'd like to tell you about some of the challenges and opportunities of transitioning to a net zero built environment. So very helpfully, Julianne has already, I'm having problems as well. Let's go. There we go. Julianne has already talked about what the Connected Places Catapult is and does, so we'll skip over this bit and get right to the material. So the vision of Connected Places Catapult is for buildings that are fit for the future. And by that we mean buildings that are low carbon, that are resilient to climate change, particularly the climate change that's already baked in, that are desirable places to live and work, and that are adaptable to changing social patterns. Buildings tend to last a long time and their use evolves over time. And most importantly, we're looking at buildings that are not making climate change worse through greenhouse gas emissions, and also not slowly killing people through poor indoor air environment. So to some of the facts, get a sense of the role of buildings in our carbon budget. UK buildings emit 115 megatons carbon dioxide equivalent a year. That's 23% of total UK emissions. And we can divide that into direct emissions, essentially using fossil fuels for space and water heating, and indirect emissions from the electricity supply. And you can see that 3/4 of the total building emissions are for heating, and over half are for heating our homes. So domestic buildings play a really important part in these emissions. And there's no transition to net zero without fixing our buildings. So what is the problem? Surely all we have to do is switch all the heating to electricity and decarbonize the grid and job's done. The problem is the mismatch between heating demand and electricity demand. As you can see, electricity demand is currently fairly stable throughout the year, but peak winter heating demand is 6 times electricity demand. And even with extensive use of heat pumps, we can't reduce the heat demand to the point where realistic upgrades to generation and the grid could cope. So we have to reduce demand by making our buildings more energy efficient, and particularly improving the efficiency of the building envelope, the outside skin of the building. There's another problem to think about, and that's embodied carbon. As we progressively decarbonize our energy supplies, the carbon cost of constructing and maintaining buildings becomes more significant. So it's been estimated that by 2050, most of the lifetime emissions of buildings, new buildings, will be embodied carbon, not operational carbon. So we have to think about how we're going to tackle that challenge as well. And obviously the best way to reduce embodied carbon is not to build in the first place. So there'll be an increasing focus on extending the life of buildings and repurposing buildings and reusing our existing stock in various ways. And this chart shows how different strategies cut embodied carbon. So build nothing, be very clever in the design and the use of low carbon materials, and then be very efficient in your building process so that you reduce waste and cut emissions on site. So that's another challenge to add. It's not just the operational carbon we have to worry about. We have to think about the embodied carbon. And there are specific challenges in decarbonising rural buildings, so buildings in a rural environment. The rural population is significantly older than the urban population, as you can see here. This is the rural population. This is the urban population. And that older population needs warmer conditions to remain healthy, and they spend more time in their homes. So it increases the pressure on decarbonisation. And the rural population is more dispersed. This is my local village. North Wales, a very pretty place, a few new homes, but mostly old, inefficient properties with poor infrastructure and connectivity. Transport connectivity in rural areas is usually poor as well, and people are largely reliant on their cars. There is a bus through my local village, but I've never actually seen it. It's not a practical alternative for most people. So that adds to the problem of how we think about decarbonising the rural environment. And rural homes are significantly less efficient than urban homes. They're typically older and much more likely to have solid walls and floors. So this is the EPC rating for homes in a major conurbation, unless you come right down to hamlets, and you can see the number of band E and band F and G properties. EPC C is seen as the minimum standard for the future. And if you look at the current situation in rural environments, this is an old and inefficient stock. And rural populations are generally poorer and much less likely to be able to invest significantly in energy efficiency. Problems such as damp are much more prevalent in rural homes. And because of the combination of these problems, fuel poverty is 27% higher in the rural population than in the urban population. And the electrical infrastructure is also a problem. Increased use of electricity for heating, cooking, and for charging electric vehicles is driving up demand. And you see a lot of buildings currently on single-phase supplies are looking to upgrade to three-phase supplies to handle the load. Quite a lot of European homes are already on three-phase systems. It's fairly unusual in the UK. And this can be expensive enough in the city, but in the countryside it can be astonishingly expensive or completely impractical. You're talking about prices to upgrade of £10,000, £20,000 sometimes. It's still very common to see electricity supplies daisy-chained from one property to another. So you're starting with the transformer here, going to one house and then just going straight on to another house and so on. And that makes it impossible even to install an EV charger. I've just had an EV charger installed, and the first thing they checked was, okay, you're in a rural environment. Are you on a daisy chain supply? Because if you are, we can't fit a charger. However, the good news in all this, it's a lot of fairly negative news, is that although decarbonising rural areas has bigger problems than urban areas, they are not fundamentally different problems. And that's important because it means the same innovations and the same solutions will help both. So that's not to kind of downplay the problems of decarbonising a rural environment, but you have this big advantage that people are looking for the innovations which will solve the rural problems as well as the urban problems. And the market for net zero buildings is absolutely enormous. These are some figures from the Construction Leadership Council's National Retrofit Plan. This looks at what needs to be done to retrofit 29 million existing homes for a net zero future by 2050. And the plan they've come up with, this is an industry-wide plan, envisages retrofitting 850,000 homes between 2022 and 2024. That would create 100,000 jobs and £22 billion worth of additional GBP. Fast forward to 2050, and they plan to have treated 2014, they plan to have treated 27 million homes. And at peak, that would have created 500,000 jobs. And that would be generating £690 billion of additional GDP. This is an enormous opportunity for companies of all sizes and for innovative products and services, because we need to change the way we do things. And there are demonstration projects already showing what is possible. This is a terrace of homes in Snayton in Nottingham. Most are social housing, but a couple have been brought under right to buy and are now privately rented. So they were not included in the retrofit project, and you can clearly see which ones were left out. The retrofit process used in this case has been called throwing a duvet over the property. You add external wall insulation, a new roof with excellent insulation and integrated solar PV, and replace all the doors and windows. Heating in this case is provided by a large ground source heat pump that serves all the properties, and there's an energy module here in this little outbuilding that has the heat pump within it, and it's based on 450-meter deep boreholes from memory. So it's quite a compact unit because the boreholes are going straight down, but that's generating all the heat that's required by these buildings. And the project was carried out using a model called Energy Sprong, which was originally developed in the Netherlands. And this is designed to pay for the cost of the upgrade through savings in energy costs and reduced repair and maintenance. So the residents are guaranteed a year-round comfortable temperature and a certain amount of hot water and electricity, all integrated into their rent. So their net outgoing should not increase as a result of the upgrades because of the savings made elsewhere. So it's a very interesting method of funding upgrades, which is being rolled out at the moment. And this is another Energy Sprong project for Moat Homes in Malden in Essex. And this, you can see a nice side-by-side comparison of the retrofitted home and the original home. And if you think about this, the character of the property has been fully retained. So it becomes easy to integrate and blend these deep retrofits into the local environment. They are not kind of going to stand out like a sore thumb, which of course tends to worry a lot of people. And you can see here, although there's deep external wall insulation, it's been covered by a brick slip, which closely models the original wall. So again, you get the same look and feel. And this is a different approach to retrofit using the passive house thinking in a rural setting. So these can be done urban, they can be done rural, the same approach can be used, and it's proven to work, great benefits from it. Problem is we have to figure out how to scale it up. And this is to show this is not entirely about retrofit and domestic properties. This is the Active Building Centre at Swansea. It's a research facility that includes this energy positive office building and classroom. It generates more energy than is required to operate and can export the excess to other buildings or back to the grid. So we've demonstrated that we can create low carbon buildings through retrofit or new build, but we have to dramatically increase the volume and cut the costs to meet our targets, and that needs innovation. So lots of different components and subsystems come together to make a net zero building. And therein lies the opportunity for SMEs, because a lot of the innovation around these specific components is coming from innovative SMEs. Everything is up for grabs. We need to change the design of the building, the materials they're made from, and the construction techniques. And unfortunately, we have to do all of that at the same time. But in my last slides, the last section, I want to show you some of the new ideas that innovative SMEs are bringing to the sector. It may spark some ideas in you, may give you some confidence to go forward with whatever you're developing. So Melius Homes was the company behind that retrofit in Nottingham that I just showed you. And they designed structural insulated panels that could be manufactured off-site and quickly craned into place to provide new walls, windows and doors. By industrializing production, they could keep costs down and they could increase the quality and prevent problems in assembly. It's an interesting one because the design of that terrace use structural concrete walls between the properties and concrete floors, but the wall panels themselves were fairly flimsy. In fact, that was one of the problems. They were telling me when they started work on this project, you could actually lean on the exterior walls from the inside of the property and actually watch them move. So the solution here was to take out those old panels altogether and then to insert these new super insulated panels with everything built in, with triple glazing, with the windows and doors already installed. And that reduced the energy consumption dramatically. A company called Agile Property have been designing buildings that use a timber structure with straw insulation to create a building which is super insulated, breathable, so it has really good indoor air quality, good humidity control, and has negative embodied carbon. It sequesters carbon through construction rather than releasing it. So as an example, a project they've worked on for social housing, 3-bedroom complex of social homes, each of those starts off life with 15 tons carbon credit embodied in the materials which have been used to manufacture the property, to build the property. So they developed a variety of use cases, and this is a 1-bedroom property that can be trailered from one location to another. This one is in Bath. It's on Airbnb, and you can stay there if you want to see at least one version of future homes. A company called Naked Energy has created solar panels that also generate hot water as a byproduct. So photovoltaic cells lose efficiency as they get hot. So Naked Energy has integrated a cooling system behind the panels and packaged the lot into a vacuum tube, so they get higher production of electricity because the panels are working at much more their optimum temperature, and you are getting hot water as well. So this is currently being used for non-residential buildings, but the domestic version will be available soon. And this is one of the technologies that's integrated into those energy positive buildings at the Active Building Centre. That was one of their major test sites for developing the technology. This is an alternative approach from a company called Synergy in Northern Ireland. It uses roof integrated solar thermal panels for hot water. The thing here is that the panels are not on the roof, as you would often see with PV or other solar thermal. They are the roof. So you keep the costs down, you make construction easier, you avoid the risk of leakage. The roof is entirely a solar thermal panel. Again, for the moment, the target is non-residential new build, but I keep chasing them and saying, when are we going to get a domestic version of that? But that's beginning to be rolled out. Ventilation is critical with energy efficient buildings as they tend to be airtight, and particularly with retrofit, there is the risk of condensation and mold, and that's a big problem if you're not careful. If you whack up the insulation and don't think and prevent the drafts and don't think about the insulation, you tend to get damp and mold because older properties in the UK are essentially designed to be ventilated through the gaps in the envelope. So this is a passive stack ventilation system from a company called Ventiv. It draws the air in a controlled manner through the building without using fans. And then it has a heat recovery system in it so that the warm exhaust air preheats the incoming cold air, so you reduce the amount of heat input required to keep the building comfortable. So you're increasing the energy efficiency. It's a really nice, really clever system. It's being used in a variety of both new builds and retrofits now. And they are expanding this concept into a prototype of an energy pod. So this is a single integrated unit that handles all of the heating, cooling, and hot water for a building. And it's a thing about the size of a large upright freezer, and can be put next to a building and connected to the building services. It can be incorporated into the building where the heating system would normally go. It's very, very flexible. And this kind of approach is very important for energy sprung retrofits, because another feature of energy sprung is you're trying to do the job quickly so it doesn't become a major disruption. And the goal with energy sprung type retrofits is throwing a duvet over the building and putting in renewable energy very quickly. You're trying to do the entire retrofit in a period of a week to 10 days. So having a pre-prepared module that you can just drop into place for the entire energy system ventilation is very attractive. So sticking with the ventilation theme, a lot of older properties have air bricks to ventilate the underfloor area. And if you block these up to stop heat loss, you cause condensation, you get rotting of the timbers. So AirX solved the problem with a smart air brick that opens and closes automatically to minimize the heat loss whilst maintaining the correct conditions in the underfloor space. So it's using data about the indoor air quality, it's using data about the environmental conditions, it's looking at weather forecasting and integrating all that together to figure out what is the right strategy for minimizing heat loss but maintaining the right conditions in the underfloor area. This is one of my favorite SME innovations because it's just so cool. This is Cubot. So insulating suspended wooden floors, which are pretty common, particularly in Victorian properties, during a retrofit, it's a pain. The traditional method is to rip up the floorboards throughout the room, install the insulation, and then replace them. This is massively disruptive and very unattractive for residents. And it's particularly a problem when you're trying to do retrofits in owner-occupied properties because you haven't got rotating voids to enable you to manage that. So with Cubot, you cut a small letterbox-sized slot in the floorboards and introduce this neat little robot into the space, and it crawls around spraying insulating foam onto the joists and floorboards. So it's an ingenious and practical solution to a real barrier to improving energy efficiency. And instead of ripping up the floorboards, installing insulation, putting them back, having to empty the room completely, take up the carpets, everything, remove the skirting boards, taking a considerable amount of time to do it, Cubot can insulate the underfloor in a day through a small slot. And Gapper tape is an innovation of pure genius for both new build and retrofit. It tackles a very obvious problem and was designed by a builder who wanted to figure out how to solve his own problem. So a popular method of insulation is to put foam blocks between joists and rafters. Unfortunately, wood is a living material that's not dimensionally stable, and it's extremely hard to fit the insulation so well that there are no gaps, even when the wood is moving with changes in conditions. And those gaps mean heat loss, and they're often substantial enough to actually defeat the purpose of most of the insulation. The solution this innovator came up with is a self-adhesive foam strip that wraps around the edges of the insulation blocks. So here you can see it. This is the actual Gapper tape, and here it is being applied to the edge of the blocks. So here are the gaps, typical gaps that you have to deal with. So you cut the blocks as accurately as you can, slap Gapper tape on both sides, and now the panel, this is a soft material, the panel is a push fit with close contact between the wood and the panel right along its length. It's fast, it's simple, it's compatible with existing building practice, it can be used by anybody. What's not to like about it? As I said, I think it's an innovation of pure genius. A very different kind of product is Saver's Intelligent Energy. This is a product for social landlords. It takes information on their housing stock, age, construction method, dimensions, condition, etc., and lets them develop a retrofit strategy. It shows them which energy efficiency measures are suitable for each property, how much they will save in energy and carbon emissions, and what it will cost to implement. That allows them to conduct what-if analyses across their stock and develop a robust plan for future upgrades. So there's lots of social landlords who understand the need to upgrade their stock, want to upgrade their stock, but are struggling to figure out what to do and how to manage their stock for energy, because that's not necessarily something they had to worry about before. Now they can get the overview. Now they can play around with, well, supposing we combine heat pumps with insulating the loft and putting some external wall insulation, what does that gain us? Do we have to go to triple glazing at the same time? Questions like that. So that's a gallop through some of the interesting innovations that I've come across. And I hope that stimulates you to think about the opportunities. Net zero buildings are vital to achieving our 2050 goals. We simply cannot reach those goals without fixing the buildings. And they will be a challenge to deliver. It is not easy, but they're an opportunity for innovative SMEs to provide the new products, methods, and services that will make it all possible. Thank you very much.
Super, thank you very much, Richard. That was really, really interesting. I think something I'm absolutely going to take away today is not all the fantastic technology you've talked about, but throwing a duvet over the building. I absolutely love that analogy, actually, when talking about retrofit. So super. Thank you ever so much, Richard Miller, again, for your presentation.